So this is an example of the cost function. So when we have the same data, employee data, so number of record is 10K and the block is 2,000 blocks and buffering factor is 5. So if, for example, clustering index on salary, it has this level 3 and cardinality is 20. And secondary index, so I think we already did this one. So yes, these are the examples. So this is the select employee using select the first name from employee where SSN is equal to 1 through 9. When you submit this query, the query optimizer will determine the cost of the disk. So for the first search, the S1, linear search is possible. So linear search, what is the cost of the linear search? So B over 2, right? What is the B in this case? B is the number of blocks. Number of block is 2,000. So cost using S1, the linear search, the cost is 1,000. Okay. Then next, can we use the binary search in this case? No. The data file is not sorted. So we cannot use the binary search, we cannot use the primary index, we cannot use the S3, S4, S5, because there's no option for the clustering index. So, however, we can use the secondary index, right? If you see the index information in this table, index underbar info, we have index on SSN, right? The second line, so employee has the secondary index for SSN. The level of index is 4. So total cost is 4 plus 1 is 5. So which one is the smallest one? Using SSN, secondary index. Okay? Actually, that is the primary key, right? So 5 is much faster than 1,000. Query optimizer decide this is the fastest way to access the employee data using social security number. Then make the plan, then access the data. In real I/O may be various, may be different from this one sometimes, because this cost function is not perfect, not exact, it's the approximation. Okay? So, however, in case of index, it's almost correct. So, the next, select employee, select the data from employee where DNO is bigger than 5. Okay? So, can you use the first option, linear search? Yes, we can do the linear search. What is the cost? It's why is not the 1,000? It's 2,000. Because it's a range query. So we need to access all the data. So that's the reason it's 2,000. What about the binary search? We cannot use a binary search. It's not ordered data. Okay? Primary index, no. Those S2, S3, S4 cannot be used in case this one, because the employee is not ordered. So we can use the secondary index. For the secondary index, which index will be used? DNO. So DNO will be used. The DNO has the level 2, right? Level 2 plus, can you remember that? This one? Where is that? Where is it? I probably delete this part, right? So why don't you go back to the S6, the second option, x plus first level of index divided by 2. That is, the first level index is the, how many IO at the
It's 4.
block? It's a 4. 4 divided by 2, right? That is, this is the index. This is a 4, right? Then this is the number of record. So brute first. So divide by 2. So total 5,004. So which one is faster?
Linear.
So linear search is faster, right? So that is the reason sometimes the index is slower than the full table scan, because especially the range query. The cutoff line, whether index is fast or not, is 5 to 10% cardinality. If the data is 5 to 10%, less than 5 to 10% less, you'd better use the index. Otherwise, full table scan is better. Do you understand? So for example, the unique data, definitely equal search for the unique data, index is faster. However, DNO is equal to something, 1, but 1 has a 20% selectivity. You'd better use full table scan. That's the idea, rough idea, because of this kind of calculation. The third one, it's not the range query, it's equal. So same thing, but this one will be different. Okay, so we can. It's a 2. It's the same thing. Then it's an exact matching. So you can have the selected how many data for DNO equal. That is in the cardinality S of DNO. That is 80. It's an average 80 actually, not exact but average, which means it's we need to total 82 times average. On average, IO. Which one is faster? In this case, indexing. Using index is faster, so query optimizer will decide this way. Using this index DNO or index, that is the 1, 2, 3, 4, 5, 6, 5. Fifth index will be used. Okay? Next. Yes.
You can't use S3, S4, S5.
This one?
No, S3.
S3?
Why we can't use S3?
This one? This option will be used for in case data file, employee file is ordered. Okay? However, in this example, we are going to use a secondary index only. Okay? The data file is not ordered. In real case, most of the DBMS, they actually do not use primary index, which means because it takes a long time to order the file. Okay? Instead, we insert as it inserted, then ordered by index or primary key. Okay? So that is the reason we cannot use. Some of the DBMS still use such a binary search and primary index. Okay? The next. This is a conjunctive query. So, this is the query retrieve the employee from employee. DNO is equal to 5 and salary is high, more than 30K and the female employee, right? At that time, we need to check for each. So brute first way is a 2000, right? It's a linear search, S1 option. In case we use DNO index, okay? That is, we already did 82. What if we use salary? Do we have the index for salary? Yes, it's the first one. It's a clustering index. Cardinality is the 20 and level is 3. So level is the 3 and this is the from this one. So it's a number of block is 2000 divided by 2 is 1003. So also we can use the sex as the index. That is, the level is 1 and cardinal is 5000. So it's very expensive. Why don't you think about how many different sex we have? Only 2. Roughly half and half. If we make the index, it's more IO we need. It's only the male or female. Right? So we need to access this one, this one, this one, then male. This one, this one, this one, female. Or if this data is even sorted male, you need to access almost half of the data file. So why don't we use the different? So this is the most expensive one. And in this case, using DNO is the fastest way. Okay? Then query optimizer will use the index for on DNO, then access the employee data. Okay? However, in your query, if you believe, strongly believe, using salary is faster, if you believe using index on salary is faster, then you can specify you can force the query optimizer select this way. Okay? Most of DBMS support such a thing. In Oracle, it's called a hint. You can give the hint to the query optimizer. Query optimizer is not perfect. As you can see, sometimes it's just guess. Okay, sometimes it's just a rough approximation. So if you strongly believe, you can give the hint. So we will see the example in the exercise. The next example is a join. So this is the example. It's the same example. So we have the 2 table, employee and the department, which has the same data statistics, the 10,000 employee and 125 the department, and how many blocks? 13 blocks for the department, 2,000 blocks for employee, and blocking factor is 5. Primary index, we have the primary index on the D number, department with the DXD number is 1. Secondary is the same as the handout information. Okay. One more thing is we have the join information. Join information is already collected. In this case, the join is DNO in employee and D number in department is a D number. It should be the D number. Then join selectivity is 1 over 125, which means 1 over 125 will be matched with the data. Okay? 10. Let's join 2 tables, employee and department. They are missing the symbol for the join. Okay? So join condition is the DNO is equal to D number. The first option is employee as the outer loop because there are 3 categories, 3 criteria to compute the cost. One is the selection, another one is join method, then the last one is join order. So we consider employee as the outer, and next one is department as the outer. It's a different order. Okay, the output will be different. Okay, then the different join. I think that we can use only one join. So first, nested loop join. So J1 is the nested loop join. The second is the single loop join. In this case, we are going to use the index for the outer join. So first one is we already learned the cost function. We can just plug in the data. So for example, employee, we have the 2,000 and 2,000 times the I think the join symbol is here. It should be up. And 2013 blocks we multiply and plus the join selectivity is 1 over 125 times number of employee, number of the department, and divide by 4 is the block. King factor for what? Buffer, join buffer. Okay, we need to put, say, the match record that satisfied with the join condition. So, if you compute this one, it's a 30,500. Similarly, we can change the order. So first, for each block, for D, then department, it's the same thing. Okay, it's the same thing. Then it will be 28,530. This is a single loop join. Single loop join, definitely it will be reduced because we are going to use the index. Okay, for the join. So this will be join. The index X D number is 1,000, 10,000. No, it's a 2. 1 plus 1, 2 times for each employee. Okay, this is the same. You will get the 24,000 and different order. Then we have the 2. This is the block. The selectivity is, I think it should be X, right?
Yes.
This should be X. So we have the 2 level plus 80. Then we will get the 12,000. Which one will be selected as by the query optimizer? So query optimizer will select the last one, which means the for single loop join. The query optimizer first suggests to access the department, then find the employee. Okay? Using index. Right? That makes sense. Why don't you think about, we have the small number of tables. For each 125, find the employee. Employee is 10,000. So we can reduce the IO. Right? Also, when we search the 10,000 employees, we can use index, very fast index. So we can reduce number of IO. That is the reason this one will be selected. Even we can prove that where DBMS system used this function to decide which path is the faster one. Okay? 2 minutes left. So this is the real case. The Oracle, in case of Oracle, use the rule-based query optimizer as well as the cost-based query optimizer. If you do not specify the option, right now, cost-based query optimizer is the default. Then, what is the benefit of the cost-based optimizer rather than the rule-based? Very important. Benefit, advantage of CBO. More accurate is automatically decide, automatically optimize. Even though that is not perfect, usually it's 80%, 70 to 80% correct. So find the fastest way to access the data. Okay, that's the benefit.
Yes.
Then you can reduce the huge time to access the data. What will be the disadvantage of the disadvantage?
It's complex.
You don't have to worry about it. It's already implemented in the software.
And it takes time to get all of the choice.
All of the, actually, for example, when we solve the previous example, this one, can you do this without this table? No. It's actually given. I gave the number of record, number of the blocks, and also selectivity, cardinality, which means if you have wrong data, output will be wrong, right? You should have up-to-date data of this one. In other words, from time to time, DBMS should collect, analyze the information about entire database. If without such information, you cannot get such a nice, perfect optimizer. That's very important. So that is the reason from time to time you need to collect the information about your database to find the best, to get the best result of query optimizer. It's a time consuming actually. How can you get such all the information? Sometimes your database size is 10 terabyte, 100 terabyte. You need to collect all the information. Sometimes not possible. So you can do sampling. You don't have to access all the data. Instead, only 10%, 5% of them. Many of the database administrators fail to refresh such information, which means my query is working very well. I submit, so it accesses very nice, very fast, but a year later, it's very slow. Okay? Why? Your query does not have any problem, but your database system does not have up-to-date information. So query optimizer use very old information. So first time, when you do not have the data, linear search is faster. But when you have huge amount of data, it should be changed. But query optimizer still take a look at all the information. So at that time, you can ask your administrator, why don't you update such a statistical information? When you are using cost-based optimizer. Rule-based, it doesn't change. As long as you keep the rule. But accuracy, rule-based, we don't know. As long as you have the index, it will use index. Right? But as we have seen before, sometimes full table scan is faster than the index search. So that's the key point. Okay, then I'm not sure. I'm thinking about the new course in spring 2014. So it's kind of the special topic in database search as well as information retrieval. At the time, I'd like to implement block-based data file as well as indexing and query optimizer. In addition to the previous, did I show you the relational database that we implement? It's a very simple relational database. Okay, it supports the very basic query and very basic relational model, but it has only the file only. So I'd like to plug in such a query optimizer to the system. It will be probably the spring semester.
It's a wonderful topic. It's a wonderful topic for research, especially for research. Yeah.
Okay, thank you, and we will see you on Tuesday next week. Okay. Why don't you check the class?